Is drying of oils. Look at here, what is a drying oil? A drying oil is an oil that hardens to a tough solid film after a period of exposure to air. When this oil is exposed to air, it will become hardened and a tough solid film will become a hard tough solid film. That type of oils are known as drying oil. This drying involves the formation of a tough organic film through the polymerization of the oil brought about by oxygen. This is the process of this is the theory of drying of oil. In drying of oil, what will happen? It involves the formation of a tough organic film, okay, through the polymerization of the oil when it is exposed to air. In the presence of air, what will happen? This oil will undergo polymerization and will form a tough film. Okay. Example of drying oil. Example is a linseed oil, tung oil, poppy seed oil, walnut oil, etc. Application of drying of oil. What is that? In oil painting. In oil painting, such oil, if you are using after a period of time, it will change into a tough solid film. Okay, so it is used in oil painting, varnishing, wood primers, etc. Okay, even in our daily life, we know that varnishing after if we put a varnish after a period of time, after a few hours, we can see that on the surface of that wood, we can see that a tough film is formed. This is because of the presence of the drying oil present in the varnish or wood primers, etc. Waxes. Wax is a lipid which comes under hydrolyzable lipids. We have discussed in hydrolyzable lipids. Wax is coming under this group of lipids. So waxes, what are waxes? Waxes are solid esters of long chain fatty acids with the long chain monohydric alcohols. When long chain fatty acids undergo esterification with long chain monohydric alcohols, we get waxes. So waxes are esters of long chain fatty acids with long chain monohydric alcohols. Now examples for waxes, the most common and the familiar wax is bees wax. First one is beeswax obtained from honeycombs and used in making candles, shoe polish, etc. Okay, first example for wax is what is that? Beeswax obtained from honeycombs. It is used to make candles, shoe polish, etc. Now look at here, component of beeswax: CH3, CH2 14 times, COO, CH2 90 times, CH3. This is a component of beeswax. Second example is carnauba wax. Carnauba wax obtained from carnauba plant. This is a type of palm tree. What is that? Carnauba plant. And it is used, this carnauba wax is used to give protective covering to furniture, protective covering to that glazing cover over furniture, cars and floors. Okay, for giving a protective covering for furniture or cars or floors, etc. We use carnauba wax. And another type of another example for wax is spermaceti wax. Spermaceti wax. Okay, spermaceti wax. What is it is obtained from the head of sperm whale. Okay, it is obtained from the head of sperm whale. What is that? Spermaceti wax. Okay, obtained from the head of sperm whale and used to make candles, ointments, cosmetics, etc. Its formula CH3, CH2 14, COO, CH2 15, CH3. So this is waxes and examples. Okay, we continue in this hydrogenation of oils. This we have studied in the lower classes. We know that unsaturated oils are unsaturated glycerides, unsaturated glycerides. When unsaturated glycerides is hydrogenated, that means treated with hydrogen in presence of nickel, it will change into saturated glyceride. This process is known as hydrogenation of oils. We know that oils are liquid in nature and oils are unsaturated glycerides. That means oils containing double bonds. Oils are in oils, the glyceride is containing double bonds. When these glycerides present in the oils is treated with hydrogen in presence of nickel, it will change into saturated glyceride. That saturated glyceride is known as fat. So look at here, this is our example. This is again this same example we are taking. This is triolin. This is our triolin. This is unsaturated glyceride containing double bond. This is oil. Triolin is an oil. This is an oil. That means this is an unsaturated glyceride containing double bonds. When this unsaturated glyceride, that is oil, is treated with hydrogen in presence of nickel, this will become saturated. That means double bond will break and one hydrogen will come to this carbon and one hydrogen will come to this carbon. So it will change into CH2, single bond CH2, or again CH2 7 times, or you can write CH2, what is that? 9 plus 7, or together you can write in a single formula. Okay, that means this is known as hydrogenation of oils. Okay, that means during hydrogenation, unsaturated oil is converted to solid. Okay, that means low melting point solid. That means it is changing to fat. Okay. During unsaturation, what is that? During hydrogenation, our oil is converted to low melting point solid, which is known as fat. Okay. So phospholipids. What is phospholipids? Phospholipids are lipids that contains groups derived from phosphoric acid. So phospholipids are lipids which contain, or that type of lipids are derived from phosphoric acids. Now look at here. This is an example for phospholipid. Okay, look at here. You can see that here is a phospholipid as another part. Here it is phosphorus and not carbon. So now look at here. Phospholipids have a polar hydrophilic head. That means phosphate ester group. This is a phosphate ester. This is phosphate ester group because here is phosphorus, and phospholipids have a polar hydrophilic head. This is the head part. This is the head. This is polar because this is a charged end, and this side is polar hydrophilic. What do you mean by hydrophilic? Water loving polar hydrophilic head. This is the head part. That means which constitute phosphate ester group. This is polar hydrophilic, and a non-polar hydrophobic tail. This is non-polar. This part is a non-polar hydrophobic, water hesitating, water hating tail. This is water hating tail. This part is water hating tail, and this part is water loving, that is hydrophilic, and this one is hydrophobic. Okay. Two of the most common alcohols forming phospholipids are ethanolamine and choline. We know that this is ester. This is an ester. Phospholipid is an ester. The ester means it is formed from an alcohol and carboxylic acid. Now look at here, two of the most common alcohols. So for the formation of phospholipids, the most common alcohols which take part in the formation of phospholipids are ethanolamine and choline. So look at here, the structure of ethanolamine, CH2OH, CH2NH2. Okay, this is ethanolamine, CH3, CH2NH2. This is amine only, ethanamine, ethanamine. One hydrogen atom is replaced by OH, therefore it is known as ethanolamine. And another alcohol which take part in the formation of a phospholipid is choline. What is the formula of chlorine? Choline, OH, CH2, CH2, N, CH3 thrice. This is choline. These are the alcohol. This is alcohol and this is alcohol. These are the most common alcohol take part in the formation of phospholipid, which are the ethanolamine and choline. Phospholipids that are esters of ethanolamine are called cephalins, and those are esters of choline are called lecithin. So phospholipid constitute of alcohol and carboxylic acid. If the alcohol is ethanolamine, then that phospholipid is called cephalins. If the alcohol part is ethanolamine, then the phospholipid is called cephalins, and if the alcohol is choline, then it is known as lecithin. Okay, so phospholipids are lipids that contains groups derived from phosphoric acid. Here you can see that a group, this is a phosphate ester group. This is derived from phosphoric acid and an alcohol. Then you are getting a phosphate ester group, and this type of lipids are known as phospholipids. Phospholipids have a polar hydrophilic head and non-polar hydrophobic tail. Now there are two types of alcohols usually constitute in the formation of phospholipids. One is ethanolamine and the second one is choline. This is ethanolamine, this one is choline. Okay, when ethanolamine is the alcohol part, then that phospholipid is known as cephalin. If lecithin is the alcohol part, the alcohol part is choline, then that phospholipid is known as lecithin. That is known as lecithin. Look at here. This is an example for lecithin. In this example, we can see that this is the structure of lecithin. In this example, the alcohol is which is the alcohol? Choline, and of course we are having a carboxylic acid. We are having a carboxylic acid. So this is the structure of lecithin, CH2O, COR. Look at here. Now you can see that when R equal to this, R equal to R dash, which is equal to CH2 14 CH3. That means R is replaced by what is that? CH2 14 times. Okay, I can write. If R is replaced by CH2 14 times CH3, and here also R dot is replaced by CH2 14 times CH3, then this lecithin, this particular lecithin is known as dipalmitoyl phosphatidyl choline. What is that? Dipalmitoyl phosphatidyl choline. Dipalmitoyl phosphatidyl choline. That particular lecithin is known as dipalmitoyl phosphatidyl choline. Okay, so that's all about phospholipids. Thank you.